Hello, am I audible? And is my screen visible? Hello, can anyone please let me know?
Yes, sir.
Okay, thank you. So, hello everyone, welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Avan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So, this is my ninth live session. I will discuss some questions on week 9 topics. And in week 9, Bayesian networks, mostly undirected Bayesian networks, were taught. So we will discuss some practice questions on those topics. And if you have any questions or queries on these topics, you can ask me during this session. So we will start solving the practice problems first. And after that, if you have any other questions or doubts, you can ask me. So this is question 1. Consider the Bayesian network shown in the figure. So this is the Bayesian network shown. This is a directed Bayesian network. You can see the edges are directed here. So there are two students, student 1 and student 2. They make two claims. Student 1 claims that probability of A given B comma D is probability of A given D. And student 2 claims that probability of A given B is probability of A. So these are the variables A, B, C, D, E given in the figure. And so these two students make claims regarding the independence of these five variables A, B, C, D, E. Um, so which of the following is true? Student 1 and student 2 are correct. Student 1 is correct, but student 2 is incorrect. Student 1 is incorrect and student 2 is correct. And fourth option is both are incorrect. So if the first claim says that this student 1 claim probability of A given B comma D equals probability of A given D. So this basically means A and B are, sorry, this basically means A and B are independent given D. And this second claim is probability of A given B equals A basically means A and B are independent given no evidence. So you have to find out which of these two statements is or are correct. You can write your answers in the chat. Anantapalli Nagal Asman Kumar says option C. Option C is student 1 is incorrect, 2 is correct. Okay. Anyone else? So for the first claim, we have to check whether A and B are independent given D. So in the diagram, this is the node A, this is the node B, and this node D is given. So we need to find out whether there exists any path from A to B which is not blocked. If that path is not blocked, then A and A and B are dependent. Otherwise, it would be independent. So this structure is similar to where A and B has this incoming edges to some node C whose descendant D is given. So this is similar to the third rule of D separation. If C or any of its descendants, in this case D is given, uh, then this path from A to B is not blocked, and if this path is not blocked, then they are dependent on each other if the path is not blocked. So A and B would be dependent on each other. So this is uh, this claim is not correct. Now the second claim is that whether A and B are independent or not, no evidence is given. So we need to check for independence of this pair A and B without any variable given or without any other evidence. So in this case, this path, if C or D is not given, in this case this path gets blocked here. If C was given, then this path wouldn't have been blocked, but C
E
is,
also, right? E also is like
yeah, E is
D, no?
also a descendant. E is also a descendant. So any descendant of C, if that is given, then that path would not be blocked. But C or any of its descendants is not given, so this path would be blocked at C. So if the path is blocked between A and B, so they are independent. So this claim is correct. A and B are independent of each other. So student 1's claim is correct. Student 1's claim is incorrect. Student 2's claim is correct. So option C is the correct answer.
So could you please explain how that student once claim, how we know we have to find out that A and B are independent, that part?
Yeah, so there were three deseparation rules. Uh, first rule was, if this is the structure X, Y, Z, the directions are important of the edges. Edge from X to Y, edge from Y to Z, so like a series connection. So in this case, if Y is given, Y blocks this path from X to Z. Y blocks this path from X to Z. So they are independent of each other. This is the first rule. Second rule is
That
this.
means if Y is known, they are independent.
Yeah, if Y is known, the X and Z are independent. Second rule is edges from Y to X and Y to Z. In this case also, if Y is known, it blocks this path from X to Z. Again, X and Z are independent given Y. Now the third rule is exactly the opposite of the first two rules. There is this. So Y has incoming edges from both the sides, from X and from Z. Now if Y or any of its descendant Y dash is given, in that case this path would not be blocked. So X and Z would not be independent if Y is given. And if Y or Y dash, any descendant of Y is not given, then this path would be blocked. So the first claim that A and B, whether A and B are independent of each other or not, given D, so this falls under this third rule. So this C has incoming edges from both the sides, similar to this third rule that Y has incoming edges from both the sides, and D is one of the descendants of C is given. So D is given in this first claim. So if D is given, this path from A to B is not blocked. So this path from A
But
to B is,
from the first statement, how did we understand that we have to find out that A and B are to be independent?
so this the first claim says that A given B comma D equals probability of A given D. So if D is given, A is probability of A is not dependent on B. That's why we can skip this B. It is same as probability of A given D. So it says that A is independent of B if D is given. So we don't need to keep B in the probability anymore, because if D is given, A is independent of B. That is the claim. Similar to the third claim, probability of A given B equals probability of A. Basically means whether B is
No,
given
that
or not, it
okay,
is.
that still that first statement. No, if D is given,
Hmm,
probably if B and D are given,
hmm.
the probability of A, and if D alone is given, and the probability of A. Those are the left side and the right side. No?
So in both the sides, D is present. So D is given overall in this statement.
That means B is dependent on D. No, actually the thing is that you are finding out the probability of A given B and D,
Yes.
and on the left side, and on the right side you're given the you're finding the probability of A given D.
Yeah. So basically means that D
That
is
means,
known, D is given.
actually,
Now whether A
if
is
actually
dependent
B
on
is
B or not.
okay, if B is dependent on D, then if we know D alone, we will be knowing A. You know,
Can you repeat your question once more?
actually, if given D alone, we need
Hmm.
A, and given B and D, we need A. That means having B is not going to add any new information.
Yeah,
That means
that
B.
is why A
No,
is
no,
not
that means
dependent on B. Yes.
no. That means B is dependent on D like that.
No,
Because
B
if
is
you know
not B.
either
No,
B or D,
we are not finding out whether B is dependent on D or not. Whether A is dependent on B or not, because
from that question, I
ultimately
did
we
not
are trying
understand
to
how to know whether we have to find out whether A is dependent
so
on D or
ultimately,
D is
no,
dependent on
let me explain. Ultimately, we are trying to find out probability for this variable A with some variables given, or whether it is given or not. That is a secondary question. But ultimately, we are trying to figure out whether the probability of A, isn't it, given some variables B and D. That is secondary. First is that we are trying to find out probability of A in both the sides. We are actually trying to find out probability of A with some variables
No,
given.
my doubt is actually suppose B and D are the same event, or if they're if
No,
D
B and D are
implies that
same
D has
event.
happened.
It becomes
No,
trivial.
no, if D implies that D has happened, something like that. That means if you know D alone, you don't need to know B at all. That way it could be, no.
Yeah,
So that means
yeah,
B
that
is
is it. That if D is known, then A is not dependent on B. This is what it says. If D is known, B is not required in the given variable set. We can skip
okay.
B. It simply becomes A given D.
And in the three rules which you have written, no,
Hmm.
if X implies Y and Y implies Z,
Hmm.
that means if Y is known, that means X and Z will be independent of each other.
Yeah, if Y is known, it
So,
blocks the path between X and Z. So if the path is blocked, they are independent.
okay.
So the correct answer would be option C. Now question 2. So this is again on a Bayesian network, but this time it is an undirected Bayesian network or undirected graph. So the edge directions are not present here. Um, Now in the undirected graph below, which nodes are conditionally independent of each other given B? So if B is given, you have to find out whether A and D are independent or not, whether D and E are independent or not, whether C and D are independent or not, whether A and F are independent or not. In each of the cases, B is given. Now you have to find out which pair of nodes is conditionally independent of each other from the options. In case of undirected graphs, it is actually much easier to
I think it's A and F.
A and F. Okay,
Option D.
okay. Anantapalli, Naga, Lakshman Kumar says B and C. Option B and option C, okay. Antaranath says option A, which is A and D. Ritikeshwaran name says option D. So in undirected graphs, to find out the conditional independence, there is only one rule, that is for the pair of variables, you have to find out whether the given variable blocks that path from all the paths from a certain node. So for, let's say, if we want to check for A and D, so A is here and D is here, and this node B is given, whether B blocks all the paths from A to D or not. And so this path we can easily see that this path exists, and that does not go through node B. So A and D are not independent of each other, because there exists a path from A to D that does not go through B. B blocks this part, but B cannot block this other path from A to D. So A and D cannot be independent of each other. Cannot be independent of each other. Now option B says D and D. So D is here, E is here, and node B is given. So there exists a direct edge from D to E, which does not go through B. So B cannot block that path between D and D. So there exists a path between D and D. So D cannot be conditionally independent of E given B. Now the third option is C and D. So C and D again. So this path exists from C and D, C to E to D, that is not blocked by B. So C and D also cannot be conditionally independent of each other given B. And the fourth option is A and F. A, F. So this path exists from A to F, which does not go through B again. So A and F are also not conditionally independent of each other. So this is also not correct. So correct answer will be none of the above. All the options are conditionally independent of each other given
So
B.
one doubt, can we have the same node coming more than once in a path?
So, you need to find out simple paths which does not contain any cycles, because you can loop like this, but you don't need to loop consider those loops or cycles. You need to find simple paths between the pair of nodes. So for undirected graphs, it is much easier to find out conditional independence if the given variable or the given set of variables, here only one variable B is given in this question, but it might also be a set of variables which is given. You just have to check whether that set of variables or the single variable blocks all the paths between the pair of nodes or not. If there is at least one path between the pair of nodes which is not blocked by the given variables, then those two nodes cannot be conditionally independent of each other. To be conditionally independent of each other, all the paths between the pair of nodes should be blocked by the given variable.
Sir, in this, can you give one example which is conditionally independent, sir?
Conditionally, because in this case all the paths are for all the pair of variables there exists at least one path. Yeah, for all the variables there exists at least one path. For example, if this age was not given between C and D, then now if we are asked to find out the independence of A and D, now they all the paths between A and D goes through this B variable, isn't it? So in that case, all the paths from A to D for which we want to find out the independence goes through B, because this this edge between C and D is blocked, is not there. If this edge does not exist in this question, it exists. But if this edge was not there in the question, then A and D would have been independent of each other given B, because all the paths between A and D goes through B.
Thank you, sir.
Now question 3. In the undirected graph given below, how many terms will be in its potential function optimization, for potential function factorization? So to find out potential function factorization for any given undirected graph, we have to find out the max clicks in the graph. Click is basically a subgraph of a given graph uh, in which all the elements are connected to each other in that subgraph, not in the whole graph. For example, this just consider this subgraph of this graph, which contains only A, B, C, D, four nodes. We can see that each node in this subgraph is connected to every other node in that subgraph. A is connected to B, C, D, B, C, D. Similarly, B is also connected to all the other three nodes in that subgraph, and C is also connected to all the other three, and D is also connected to all the other three nodes in this subgraph. So this forms a clique. So clique It's called a clique. And to find out the potential function factorization, we have to find out the max cliques. So max clique is a clique which cannot be extended any further. So for example, this can also be considered a clique of this undirected graph ABC, because A is connected to the other two nodes B and C within this subgraph. B is also connected to the other two nodes. C is also connected to the other two nodes in this subgraph ABC. But we can extend it to D also, because D is also connected to all the other three nodes in this subgraph of ABCD. So this subgraph ABC, this triangular subgraph ABC is not a max clique, because we can extend it further so that all the nodes within that subgraph is connected to each other. But this rectangular subgraph ABCD, this is a max clique because we cannot extend it any further. We cannot add any more variable, any more node from the rest of the graph to this subgraph, so that it still remains a clique. If we try to add this node E into this subgraph of ABCD, E is connected to only A and D, but it is not connected to B and C. So including E would not make it a clique anymore. So that's why this rectangular subgraph of ABCD is a max clique.
So connected means directed should be there, or any path from that node to the other node is enough.
So these are undirected graphs, so you don't need to consider directions. Also, directions would not be given because these are all undirected graphs.
No, so actually A is connected to F through B, no? So is A connected to F or not?
No, you have to find out if all the variables within that subgraph is connected to each other or not. There's this rectangular part only, A, B, C, D. A is connected to all the other three nodes in this
No, no, my
rectangular
doubt
subgraph
is
only.
in this graph, is A connected to F because there is a path between A and F.
Yes, A is also connected to F, certainly, because these are
Uh,
undirected.
yeah, but then why did adding E, whether that part could you explain once again, that when you said by adding E it no longer remains a clique, no?
Clique means all every node within that subgraph should be connected to every other node within that subgraph. A is
Yeah, but
connected.
E, yeah, E if you add E is connected to A,
No,
D, B and C, no?
connected. No, connected basically means, I mean, direct edges are present, not that you
That is
have
it.
a path
It's not
between.
connected. It
Yeah,
is a direct
yeah,
edge only.
yeah.
Okay.
That was my mistake. That
Okay.
you have to
Okay.
check whether direct edges are present or not.
Okay.
Certainly, all the nodes are connected to all the other nodes in this graph because it's a connected graph. But you need to find out the direct edges. So the node A is directly connected to A, B, D through direct edges. Similarly, B also has direct edges. So that's why this part ABCD is a max clique. This is uh, one factorization, one factor for the potential function factorization. The other one would be this triangle ADE. This is also a max clique because in this triangular subgraph AED, every node is connected to every other node, uh, but you cannot extend it any further. If you try to add this node B only. Uh, there is an edge between A and B and A and D, but B does not have any edge between B and E. So B is not directly connected to E, so you cannot extend it by including B. Similarly, you cannot add C also. You cannot add C also in this triangular subgraph. So this is another max clique, and the other max clique would be this one, BFC. So this is again a max clique because you cannot add any other node to this clique to make it a larger clique. So these are the three max cliques that you can find out: this rectangular part of ABCD, then this upper triangle of AED, and the lower triangle of BFC. So these are the three max cliques you can find out. So you have to find out how many max cliques are present in the subgraph. That would be the number of terms present in the potential function factorization. So option B3 is the correct answer.
So actually in this graph, no, A, B, C is a clique, but it's not a max clique.
ADC.
ABC.
Yeah, ABC, this triangle is also a clique, but that is not a max clique because you can still add D to it and it would still remain a clique. So that means you can
Okay.
extend it further. So these are the factors that we can find out, ABCD, AED and BCF. So these are the three max cliques present, and these also represent the factors of this undirected graph. Question 4. Consider the following Bayesian network containing three variables: rain, sprinkler, and wet grass. The random variables in the given model are modeled as discrete variables: rain, sprinkler, wet grass, and these are binary variables. Are so, for example, this symbol of this represents negation of S. So these are all these variables are binary variables, and corresponding probability values are also given. These are the given probability values, and you have to calculate probability of S given W and R. So this is R, this is S, and this is W. Antara now it says option C, which is 0.22. Okay. So this probability calculation might seem slightly difficult to understand, but we simply need to use the Bayes theorem to compute this. So this is the probability that we need to find out, probability of S given WR. This is the probability that we have to find out. So we will apply Bayes theorem to it. So using simple that we know that probability of A given B equals probability of AB divided by probability of B. So this is the definition of conditional probability distribution. So we simply apply it here. So now we need to compute this probability of SWR and probability of WR, and further we can write probability of WR as probability of WRS plus probability of WRS complement. So probability of WR is basically the total probability considering all possible values of S. So we can split it as probability of WRS plus probability of WRS complement or negation of S. Now, so we need to compute probability of SWR, which is in the numerator, this probability of WSR. Now we will again use conditional probability formula. Probability of W given SR, because we know this probability value from the given data. Probability of W given R or S are these two are equivalent. So probability of SWR is equal to probability of W given SR into probability of SR. And from the Bayesian diagram, we can see that rain and sprinkler, this R and S variable, these two variables are independent of each other because they don't have any connected path between these two. So this can be written as probability of S into probability of R. So this becomes probability of W given SR, probability of S into probability of R. So probability of SR is given here, probability of S is given here, probability of R is also given here. So you can put these values into this formula and just compute the value for probability of SWR. And the other probability value that we have to find out is this probability of WRS complement. So there would be probability of WRS complement, similar to what we did for the other probability calculation. We will again apply this conditional probability formula, and this R and S, these two variables are independent of each other, so we can split the probabilities like this: probability of R into probability of S complement. So this probability of W given R S complement is given here, this one, and probability of R is also given. Probability of S complement would be 1 minus probability of S. So this is just 1 minus probability of S. Probability of S is given in the question, so you can again put these three values into this formula to find out the probability of W comma R comma S complement. And once you find these two probability values, you have to put the values into this formula to find out the probability for S given W comma R. So the calculations might seem slightly difficult to understand, but you just have to apply the conditional probability definition in every step so that you can use these given probability values.
Sir,
Yes.
uh, here in condition probability values are given below. In this last is there P of W.
Hmm.
Then after that, before R and before S, what are the symbol is there? What is the
So
meaning of that one, sir?
this negation of this is negation of S, similar to S complement. So all
Okay,
these are, yeah, all these
S
variables.
complement, sir.
Yes, complement of S. All these three variables are binary variables. So S means it is S equals true. Negation of S means S equals false.
Ah, yes, sir. Yes, sir. Thank you, sir.
Moving on to question 5. What is the naive assumption in a naive Bayes classifier? All the classes are independent of each other. All the features of a class are independent of each other. The most probable feature for a class is the most important feature to be considered for classification. All the features of a class are conditionally dependent on each other.
B for Bombay.
B, okay. Anyone else? Antaranath says option B. Sweta Lakshmi says option B. Yes, so the correct answer is option B. That for a given class, all the features are independent of each other. So that is the naive assumption in a naive Bayes classifier, but it might not hold in all the cases. That's why naive Bayes is not applicable in um, all examples or all tasks. If we are certain that all the features are independent of each other for a given class, then only we can apply naive Bayes classifier. But in most of the realistic tasks, this might not hold. Now question 6. Which of the following graphical models capture the naive Bayes assumption where C represents the class level and Fi represents the features. So F1, F2, F1, F2, F3, Fn, these are the features, n different features, and C is the class variable. So which of the following graphical models capture
Yeah,
the
yes,
naive
sir.
Bayes?
Yeah.
A, okay.
A for apple.
Okay. A. Sweta Lakshmi says option A. Anyone else? Antaranath says option A. So in naive Bayes classifier, F1, F2, Fn given C can be written as F1 given C, probability of F2 given C up to multiplication probability of Fn given C. So this C, each of these features uh, is dependent on this class variable C. So F1 given C, so there should be an edge from C to F1. There should be an edge from C to F2, and also the direction of the edge is important here. F1 is in F1 depends on C, so there should be an edge from C to F1. Similarly, there should be an edge from C to F2, and there should be an edge from C to Fn. So C would be the variable and the class variable, and if these are the features, there should be an edge from C to F1, there should be an edge from C to F2, and there should be an edge from C to Fn. So option A is correct. The Bayes assumption states that the given class variable features are independent. This is captured when the class level is the parent node for all the feature nodes. Now question 7. So this figure is similar to one of the questions that I solved earlier in this live session only. The only difference is that uh, in that question the edges were directed, something like this. but in this figure now the edges are undirected. So this becomes an undirected Bayesian network, also called Markov network. And again, two students are making two claims, student 1 and student 2. Student 1 claims that probability of A given B, so this is A and this is B. Probability of A given B is probability of A. So basically this claims as the probability A is independent of B. And student 2 claims that probability of A given B comma C is equal to probability of A given C. So this C is given, we have and the student 2 claims that if C is given, A and B are independent. So second claim is that A is independent of B given C. And now you have to check whether both these statements are correct or one of these two statements is correct. And now in this example, the edges are undirected here.
Student 1 claims is correct, but I am not sure about student 2.
Okay. Antaranath says option B. Option B is 1 is incorrect, 2 is correct. Okay. Shweta Lakshmi says option B. So the first claim is that A and B are independent without given any evidence. So this A and B, and this is an undirected graph. So in case of undirected graphs, we just have to check whether there exists a path between the pair of nodes for which we want to find out the independence. So in undirected graph, no variable is given, so this path from A to B certainly exists. And if this path exists, then A and B cannot be independent of each other. They are dependent because this path exists. So first claim is incorrect. Second claim is A is independent of B given C. So now A is independent of B given C. So in undirected graph, again we have to check whether uh, there exists a path between A and B that does not go through C. C is given, so C would block the path between A and B. So this path would be blocked at C because C is given. So if the only path between A and B is blocked by C, so A cannot be independent. A is independent of B. So the path does not exist. A is independent of B given C. So second claim is correct. So correct answer would be student 1 is incorrect, student 2 is correct.
Sir, excuse me, sir. Explain the first case, sir. Student one.
So student 1's claim is that A and B are independent of each other. So that's why probability of A given B equals probability of A, means A and B are independent of each other. So A and B are independent of each other. For that we have to check whether there exists a path between A and B. So this path exists from A to B, isn't it? So if there is a path from A to B, then A and B are dependent on each other. So they cannot be independent of each other. So that's why first claim is incorrect. But in the second claim, C is given. In the second claim, the C is given, so C would block this path between A and B. So any given variable blocks the path in case of undirected graph. So in case of directed Bayesian networks where edges have directions, the three rules are there. You need to check which rule is applicable for which path and which part of the path. But in undirected, the given variable blocks the path. So C would block this path from A to B if C is given. So if the path is blocked, A and B becomes independent of each other.
Okay, sir. Thank you.
So, sir, that means A and B are independent only if C is given, otherwise not.
Yes, so C is the only node that exists between A and B. It comes
Okay.
in that path.
D, but if D or E is also known, whether we can say that if
No,
C is not known, but
if D is given for A and B, D is given D. This is an undirected graph, so this path would still exist. A to B. D would not block that path. In undirected case, we just have to check whether the given variable blocks that path or not. So also E cannot block this path from A to B. But only if C is given, only C can block this path from A to B. D and D cannot block the path. So even if D and D are given, this path from A to B would not be blocked, and they would be dependent on each other. Now question 8. So this is a Markov network or undirected Bayesian network. Which of the following variables are not in the Markov blanket of variable 4? So this is the variable 4. So you have to find out the Markov blanket of this variable 4 in this Markov network, and then you have to check which of the following variables are not present in the Markov blanket of 4. So multiple answers may be correct. You have to find out which of the following variables are not present in the Markov blanket of variable 4. So the Lakshmi says D and G. So D is 5, G is 7. Leah, Anu, George says 5 and 7. Anantapalli, Naga, Lakshman Kumar says D and G. So the Markov blanket of a given variable is simply the immediate neighbors of that variable. For example, for this node A, the immediate neighbors are node 2, node 3 and node 4. These are the three variables uh, which have direct edges from node 1. So node 2, 3 and 4 would be in the Markov blanket of node 1. So immediate neighbors are present in the Markov blanket.
So the answers are 5 and 7.
5 and 7. Okay, so for node 4 we can see that the immediate neighbors are node 1, node 2, node 3, then node 6, node 8. So the Markov blanket contains 1, 2, 3, 6 and 8, but there doesn't exist any direct edge from 5 to 4 and there is no edge from 7 to 4. So 7 and 5, these two variables would not be present in the Markov blanket of variable 4 because there is no direct edge um, from these variables to 4. So 5 and 7 or option D and G are the correct answers. Option D and G, so 5 and 7. Now question 9. So for the same Markov network, uh, two students make two following claims. Manish claims variable 1 is dependent on 7 given 2. So variable 1 is dependent on 7 given 2. This is the first claim. Trina says variable 2 is independent of 6 given 3. So these are the two claims. Now you have to check which of these claims is or are correct. And again, this is an undirected Bayesian network. So edge directions are not given, and also you don't need to consider edge directions. Shweta Lakshmi says option B. Leah Anujor says option B. Option B says Trina is incorrect. Manish is correct. Okay. Antarnath says option C. C is Trina is correct. Manish is incorrect. M Sanvi says option B.
A for apple, sir.
A. Okay. So for the first claim, we have to check the independence between A and 1 and 7. 1 and 7 given 2. This node 2 is given, and now we have to check whether 1 is independent or of 7 or not. So for undirected graphs or Markov networks, we just have to check whether all the paths between 1 and 7 goes through 2 or not. 2 would block those paths. So as we can see, this is one path, 1 2 7. This is one path, and the other path is 1 2 5 7. So these are the only two paths, and both the paths go through 2, and if 2 is given, 2 would block both the paths. 2 would block this path, 2 would also block this path. Both the paths between 1 and 7 would be blocked by 2. So if all the paths between 1 and 7 are blocked, then 1 and 7 are independent of each other, but the claim says dependent on each other, so that would be incorrect. Now the second claim is 2 is independent of 6 given 3, and we can easily see that there is a path from 2 to 6 that goes through 4, and 3 cannot block that path because 3 is not present in that path. So this red line represents that path. So there exists a path between 2 and 6 which cannot be blocked by 3, which does not go through 3. So 2 and 6 are dependent on each other. So if 2 and 6 are dependent on each other, this claim is also incorrect. So both students are incorrect. Both the claims are incorrect. So in both the cases, we see that in the first case, we see that there does not exist any path from 1 to 7 given 2, so that claim is false. And in the second claim, there exists a path from 2 to 6 which is not blocked by 3, so that claim is also false. So both the claims are incorrect. So these were the practice questions that I wanted to discuss in this live session. Now if you have any other questions or doubts, you can ask me.
Yes, a question for that rain
Sir,
sprinkler.
if you don't
Question 4.
independence and independence, I didn't understand quite well.
Okay, let me first explain question 4 once, then I will answer the other question.
Yeah, this also I didn't understand.
So question 4, this is the formula this is the probability value that we have to find out. Probability of A is given WR. So using conditional probability definition, we can write it like this, because for two events A and B, probability of A given B is probability of AB divided by probability of B. So probability of
That
A
is
is given
A intersection B by P, P of A intersection AB by P of B, right?
P of A, yes, AB means A intersection of B. It is simply written as
Okay.
AB or A comma B also. So probability of A is given WR, we can write it like this: probability of SWR divided by probability of WR. So this is
Sir,
using yeah.
based based on the diagram which is given over there,
Hmm.
so using the third rule, isn't it that the R and S are independent when W is given?
When W is given, R and S are not independent,
Huh,
because
not independent.
you
Okay,
have to consider these directions, but
okay,
you don't need to analyze whether they are independent or dependent, because these probability values are given. You just have to
okay,
use these probability values to compute it. For this question, you don't really need to analyze the independence of the variables.
okay,
So probability of SWR in the numerator, then probability of WR in the denominator. So this denominator probability of WR can be rewritten as this: total probability considering all possible values of S. There are two possible S is missing from this denominator WR, so we can introduce S by considering all possible values of S, then taking the sum of those probabilities. So probability of WRS and probability of WRS complement. So now we have to find out this probability value, probability SWR and probability of WRS complement. So this is the probability of WSR. Now again we apply the conditional probability definition: probability of W given SR, and probability of this whole thing is probability of SR, and S and R are independent of each other, so we can write it as probability of S into probability of R. And the other term that we have to find out, probability of S W S complement R, is also computed similarly. So basically you have to repeatedly apply the conditional probability formula or the Bayes formula to make it in such a form that you can apply the probability values that are given in this question. So these probability values are given. You have to transform the probability that you are asked to compute in such a way that you can use these given probability values using simple Bayes theorem or the conditional probability formula. Is there any other question?
Can you please explain the independence and non-independent
So
or dependent?
in case of undirected graphs, this is very easy. That, for example, here that so if we want to find out the independence of A and D given this variable B, so this is an undirected graph. So we have to check whether there exists a path between A to D or not. Uh, B would block any path going through B because B is given. So this path, if you consider this path A, C, B, D, this path would be blocked at B because B is given. But this path ACED, this red path, cannot be blocked by B because this does not go through B. So there exists a path between A to D that does not go through B. So this path is not blocked. If this path is not blocked, A and D are connected. So if A and D are connected, they are dependent on each other. So they are dependent on each other given B. So this represents independence and this would represent dependence. So A and D cannot be independent of each other given D. So in undirected graphs it is very easy. The given variables would block any path going through those given variables. So you have to check whether there is any other path that does not go through those given variables. If there exists
The language is quite funny, sir. You're saying actually, so if the B is given, what is the meaning of B is given?
B is given that probability of, sorry,
You know the value of B,
yeah,
right?
probability of A given B. So I know the value of B. Now whether, how can I find out probability of A? If probability of A given B equals probability of A, so if I know B, it does not affect probability of A. So that's why A and B are independent in this case. If probability of A given B equals probability of A. So if A is independent of B. Knowing B does not give any information about A. So in this
Okay.
the
So,
yes.
so in this case, suppose if you know B,
Hmm.
still have a path from A to D, so other way.
Yes.
So A and D are independent, right?
A and D are dependent. If there exists a path, that means they are dependent.
Okay.
If there exists no path, then they are independent.
So let us say there is no line between C and E.
Yeah, in that case,
I think
that example
you
I
explained
already
this.
have shown there, that
Yeah.
if this path does not, this edge does not exist between C and D. Now there are
Okay.
two paths that go from A to D, this blue line, and the other one is this green line, ABED, and ACBED and ACBD. This, there are two lines, green and this blue. Both the paths go through B. So if both the paths go through B, B would block both the paths.
Okay.
In that case, B would block both the paths, so A and D are not connected. So A is independent of D given B.
Okay. 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 Something maybe I got. So where can I look at these kind of problems, sir?
This kind of problems, I mean, to understand it again properly, you have to find out YouTube YouTube videos. There are many YouTube videos on these
So what
topics.
topic would be?
Bayesian
Uh,
network independence, you can just search in YouTube.
oh, okay.
The
Thank you.
rules are properly explained also there.
Thank you. Thank you very much.
Is there any other questions?
Can you explain something about factorization with some example?
So example, the
Given
example,
indirectly.
the example that I have shown there in this question. So basically, you have to find out those.
Potential.
You have to find out those clicks. This is one click,
Mm-hmm.
max clicks. So you have to find out max clicks. This is another max click. You cannot. This is a click, and you cannot extend it
Mm-hmm.
further. And this is the third one. So you have to find out such max clicks, and you have to also make sure that combining those max clicks cover the whole graph. You cannot leave out any variable. So you have to make sure that all the variables in that graph is also covered by combining all the max clicks. So these three max clicks would cover all the variables and also all the connections or edges in this graph.
Okay.
Any other questions or doubts? So if there are no other doubts, we can end this live session now. Thank you everyone for joining. We will meet again next week.
Thank you.
Is someone saying anything? I cannot hear properly. So thank you everyone for joining. If there are no other doubts, you may leave and we will end this meeting now.